Hi everybody, welcome back. So we're going to take this circuit now and we're going to address how do I come up with some values and use the method of polar form. So polar form is using the magnitude and the angle of each component to determine my total circuit values. So we have established we have 3 resistors and I have an inductive component in my circuit. So the very first thing that this will address is how to solve for the total circuit impedance. So my total circuit impedance is going to be a factor of all of these devices, okay, at their appropriate phase angles. So in a series circuit, my total opposition is just added directly together. So I will have R1 plus R2 plus R3 at their appropriate vectors. So it's not just taking the unit, the magnitude of that value, but it's also taking at its appropriate phase angle. And I will also have my XL taking into account its appropriate phase angle. So I'm in order for that vector, in order for that value, I need to understand the property of that and add it at its appropriate angle. So each of my resistance, they're an in-phase component. There's no reactive component. So those will always be in phase with my reference. My reference is my EMF, my voltage, because it's the constant. That's why it is E in my circuit. My electromotive force is my constant. So my resistive component will be in phase with my voltage, which will cause an in-phase current. So I will have 4 ohms at 0 degrees plus 4 ohms at 0 degrees plus 4 ohms at 0 degrees plus my 10 ohms at 90 degrees. So those are my 4 components added at their appropriate phase angles. Okay? So when I calculate this and I add those at their appropriate value, I get a total circuit impedance. I'm going to switch colors. I'm going to make this blue. I'm going to have 15.62 ohms at an angle of 39.8 degrees. Okay, so that's where my circuit impedance lives. So I hope this has helped. This is a nice simple way. What I really like about this is my circuit angle is present already, and I can use that for lots of different comparisons. Okay, but that's where my total circuit impedance is at my the phase angle for this circuit based on these properties. So I hope this has helped. We're going to be moving forward. We're going to calculate some total current values using the polar method. We're going to calculate total power using the polar method. So I hope this has helped. If you have any questions, feel free to reach out, and I look forward to seeing you in the next one.